Hello and welcome back to your Algebra 1 Semester 1 final review. We're looking at problem 40, which has to do with Tandy and her outfit choices. Just a reminder that as long as your problem looks like this, even if the problem number is different, it is still good to go. I just am too lazy to re-record these every year. So, here we go. Tandy has at most $100 to spend. Shorts are $12.50 a pair. Tank tops are $6.25 each. And we're looking for which graph represents all the possible combinations of shorts and tank tops that Tandy can buy. Now, before we even do any math, we need to look at these graphs and see what they've done here. All of these graphs have a boundary line, which is this line right here. And you'll notice that this boundary line is separating two sides of the graph. It's separating the side of the graph that's shaded from the side of the graph that's not shaded. In fact, A and C are the exact same graph, except A has shading on this side and C has shading on this side. Take a look at the Y and the X-intercepts to see that they are the same boundary line. Okay, and then you'll notice that B and D are the same thing as well. Now the question becomes, first, which boundary line is correct, and second, which shading is correct. And I'll give you a couple different ways to look at that. We're going to go the algebraic, the equation approach first. So, shorts are $12.50 a pair. Now that means, and notice down here, that shorts are going to be our X. We don't know how many pairs of shorts we're buying, but if shorts are $12.50 a pair and you bought, let's say, 5 pairs of shorts, think about how you'd calculate the total amount of money you're spending on shorts. And hopefully you said, oh, we just do $12.50 times 5 or times however many pairs of shorts we buy, and you'd be correct. So to find the total amount you spent on shorts, we just do $12.50 times an amount. However, we don't know how many Tandy is buying, so we're going to say she's buying X shorts because shorts is on the X-axis. Okay, and then after she buys shorts, she's still looking for tank tops. Same idea though. Tank tops are $6.25 each, so $6.25, and we're going to multiply that by another variable. It looks like tank tops are on the y-axis, so let's call it y. So if the orange represents the total amount of shorts and the purple is the total amount of tank tops, if we want to find the grand total of everything, we need to add these two together. And we know, based on Tandy's allowance for summer clothing, that when we add these together, they could add up to 100. Or if she has at most 100, she could be satisfied after 1 pair of shorts and 1 tank top. So that means that although she could spend money equal to 100, Tandy could also spend less than that. This is the equation that should be graphed on either A, B, C, or D. In order to determine which one, we're going to look at 2 parts. We'll start with the boundary line. The boundary line is what separates the shading from the non-shading. And the way we do it is we actually just go through and we graph this equation like there was an equal sign instead of a less than. So just equals 100. Now my favorite trick when you have x and y on the same side of the equal sign is to replace the x with 0 to find your y-intercept. And then start over, replace your y with 0, and find the x-intercept. Okay, well to do that, we might as well label the work. Our x-intercept still needs to keep an x in here, but we don't want the y to get in the way, so we're going to replace that with 0. And this is going to build the point sum x, comma 0 for y. Well, 6.25 times 0 cancels out. That just becomes 0. So a lot of people, when they find x-intercepts like this, they just cover up the part with the y, and that gives you the equation to solve for x. So all we need to do is 1250 times x has to be 100. And to figure this out, we're just going to go through and, of course, isolate x. And when you isolate x, that just means divide off the 1250 from each side. You might want a calculator for this, so take a second, type it in, 1250 or 100 divided by 1250, and when you finish that, you should end up getting an x-intercept of 8. Or you could think of it as the point 8, comma 0. So check back on your graph and think, well, which one has that blue boundary line going through the x-axis at 8? Well, I see 8 here, 8 here, here, and here. Well, I think we can already eliminate B and D. They have the wrong boundary line. Now, if you wanted to find the y-intercept, you would just do the exact same thing, but you would have to set your y part equal to 100. So 6.25 times y equals 100 and solve. I'm not even going to do the math though, because these last two boundary lines are the same. They both have a y-intercept of 16, so I would bet pretty strongly that this answer is 16 without even using a calculator. Okay, so we've narrowed it down to A versus C. Then we need to talk shading. The way that the shading works is the shading is trying to show us all the possible combinations that Tandy can buy and still stay within her $100. So you'll notice that one graph is shaded on the right or above the blue line and the other one's shaded on the left. So let's just pick a couple points there. For example, maybe I'll pick the point 10, 10. That's in my shaded region here. And over here, what if I pick the point 2, 2? If a point is in the shaded region, that means that the point should be a viable or a possible option for Tandy. So we need to think, is the point 10, 10 okay for Tandy? Or will that cause her to spend less than $100? And that's pretty easy to check. We would just plug 10 in for x, 10 in for y, because the point is of course 10, 10, and we do the math. However, 1250 times 10 is 125, just moved the decimal ones, and that's already way too much. So it shouldn't surprise you that all the points on this shaded region are going to be way too much. They're all going to be over $100. And so if you try the point 2, 2, I'm pretty sure that will cause our equation over here to stay under that $100 limit. And that is exactly what our blue boundary line is doing. The boundary line is separating all the points or all the combinations of clothes that will cost less than $100 versus more than $100. And it's really nice to have that visual. She might be thinking, well, I really want to buy, 4 pairs of shorts. Would I still be able to buy any tank tops? And the answer is yeah. Look at all these different combinations right here. However, if Tandy says, well, I want to buy 16 pairs of shorts, are there any tank tops I could do? The answer would be no, you can't do that because every point out here is not in a shaded region. So our answer is C. Hopefully that helped, and good luck on your final.